All right, ladies and gentlemen, boys and girls, today I want to show you guys a little bit more of an advanced technique from physical science. It's something you would actually learn in physics. If you take physics, today we're going to talk about using a velocity time graph and actually using the values on that or velocity time graph to figure out how far an object's gone and to start figuring out where it actually is, right? How far it's gone, we're actually going to be looking at the displacement. We're going to find out how much that object moved given the velocity time graph. And so what we're going to do basically is we're going to use some very basic geometry and we're going to use a little bit of algebra. And that's real simple stuff here. All right. So just real quick to kind of set up here, we're going to be looking at the displacement, which is change in position or the final position minus the starting position. So we want to find out how much from where we started to where we ended based on a velocity time graph. All right. So I have here a velocity time graph where I went a constant 3 meters per second for 3 seconds. And then I went for the next 7 seconds, a constant negative 2 meters per second, or 2 meters in the negative direction. Assuming I start at the positive 3 meters per second, all right? So if I'm assuming I'm starting at this point right here, I want to try and figure out where I would end. What would be my final position, all right? And so I'm going to show you guys how to do that. And the short answer is what we have to do is we have a line here, and what we're going to do is we're going to find the area under that line, all right? So what we would do is, so I see this as kind of two parts, right? I have this first part here where I went 3 meters per second for 3 seconds, all right? And what it did here is it creates like a little box. Right, that little box in there. If I find the area under that line, that will tell me the displacement. All right, it won't tell me where I ended, but if I already know where I started and I find the displacement, I can figure out my final position. All right, so I just told you I went for 3 seconds at positive 3 meters per second. 3 times 3. Which makes my displacement positive 9 meters. Which means during this 3 seconds, my displacement is positive 9 meters. Which means I went from here, and I went 9 meters in the positive direction in 3 seconds. So in 3 seconds, I would end up at positive 12 meters. That's where I ended up during that 3 seconds based on the area of that curve. That's my displacement, but that's my displacement just for that section. We got a whole 10 seconds here, all right? So for my total displacement, the first part I did was a positive 9 meters, all right? But now we have a second part here, all right? I have another box here. Right now, we're just going to be doing boxes because we're doing constant velocity. Eventually, you can do the same thing here with triangles instead of squares and rectangles once we start talking about acceleration. So in this case here, I went a negative 2 meters per second for a total of 7 seconds, or length times width. It's going to be a negative 14 meters during that time. So just for the second half of this, starting at 3 seconds, I'm at the positive 12 meter mark. Because I did the starting 3 meters plus the 9 meters I moved in the positive direction. Now I'm going to be going negative 14 meters. All right. Okay, I had to make a quick correction because I don't want to make this more complicated than it needs to be. So we're going to assume right now that I actually went, at this point here, I didn't go for a total of 7 seconds. I only went for a total of up to 8 seconds. So from 3 seconds, starting at 3 seconds, I'm doing negative 2 meters per second until 8-second mark, or for a total of 5 seconds. I just made that switch right here because otherwise the numbers wouldn't have gone into negative positions, just make it a little bit more challenging than it needs to be right now. So if I was going to find the area under that curve, negative 2 times 5 is negative 10 meters. All right, sorry about the little change there. So in this case here, during this part right here, the blue part, I went negative 10 meters, or 10 meters in the negative direction. So if I'm starting for this part at positive 12 meters, I go 10 meters in the negative direction all the way to 8. That's going to put me down to positive 2 position. All right, because my displacement during that section right there, right, my displacement at that section right there, I'm going to add my second part there, is negative 10 meters. All right, so my overall displacement, when I consider the first two parts, all right, the part where I went faster for 3 seconds and the part where I went slower for 5 seconds, if I combine those two together, I'm going to have a total displacement of positive 9 and negative 10 makes negative 1 meters. All right, so if I want to know where I ended up, all right, just doing the math, all right, I know final position minus starting position has to equal this number. So in that case here, positive 3 minus some number, some number minus positive 3 has to equal negative 1. The correct answer is positive 2. If I want to make sure, final position is positive 2 minus 3 equals negative 1. All right. Sorry for the little hiccup there about the calculations, just to make it a little bit easier, but that's how we would find the total displacement given the area of the area under the line on a velocity time graph, assuming constant velocity. This is a topic you would do as a regular topic in physics. Physical science, this is kind of more of above and beyond. So I hope that helped. Hopefully you guys can answer some of those extra problems. All right, good luck. Thank you.